All right, today we're going to be talking about EMF and Gibbs free energy. So EMF we'll start with is electromotive force. So what an electromotive force is the potential difference between the two electrodes, which produces the driving force that pushes electrons. We see that creates a voltage. So we have our equation here. So E naught of the cell is equal to E naught of the reduction of the cathode minus E naught of the reduction of the anode. So we have our standard reduction potentials on page 627 in our textbook. We'll post a link on Google Classroom so you guys have that. And good news for you guys, we're not going to do any multiplication with this stuff. So a little bit easier. We'll do an example here. So we have copper 2+ plus zinc goes to copper plus zinc 2+. So we're going to split this like we do with our half reactions. So we have our copper 2+ going to copper and our zinc going to zinc 2+. We have to balance those out. So all we have to do is add electrons to balance out the charges on both sides. So we're gaining 2 electrons over here with the copper, which means it is a reduction, or rig. And then we're losing 2 electrons with the zinc. So it's an oxidation. So that's OIL, oxidation is losing, reduction is gain. So we plug in, we have our equation there. So we have the E naught cell equal E naught reduction of the cathode minus E naught reduction of the anode. We have to look on that chart in the books. We get our values for the reduction potential for our copper and our zinc. Have those, we plug those into our equation here. Instead of subtracting a negative, we're going to add a positive, and we get our answer of 1.1037 volts for our cell. All right, do this one together in class. Leave yourself a couple lines of room. Next, we have Gibbs free energy. So you guys have seen this before. It's delta G. So that's what that triangle is, delta G. It's the change in G, Gibbs free energy. So it's the measure of the spontaneity of a reaction. So how spontaneous the reaction is. So we have our equation, delta G equals to -N times F times E naught. So we know that N is the number of moles of electrons in our equation. F is Faraday's constant, 96,500 joules per volt mole. And then we have our E naught is equal to our standard EMF. So we'll do an example here. So find the Gibbs free energy of the silver nickel voltaic cell. So we set up our, we have our equation for Gibbs free energy. We have a few things that we don't know for this. Faraday's constant is constant. We always know that one. So we need to find the N and the E naught. Let's find the E naught first. So let's set up our 2 half reactions. So our AG, our silver, go a silver plus an electron goes to silver, and then our nickel goes to nickel 2+ and 2 electrons. So we have on the left, it's gaining an electron, so it's a reduction. And on the right with nickel, we have it's losing electrons, so it is oxidation. So we find our values on the table again. Again, we'll post that up on the Google Classroom so you guys can see those. Plug those into our equation. Instead of subtracting a negative, we're going to add a positive. Get our answer for E naught. Now we have to plug that into our Gibbs free energy equation. So we have the Faraday constant, we have our E naught. All we need now is our N, our number of electrons. So in our example here, we have 1 electron being transferred in the silver and 2 electrons being transferred into our nickel. We're going to go with our common multiple. So we do 2 electrons. Common multiple of 1 and 2 is 2. So we get -2 times our Faraday constant times our E naught. We get our value of -204,000 joules per mole. We don't like it as a big number like that. So we convert it to -204 kilojoules per mole. That's our final answer there. All right, we'll do this one together in class. I will see you then. Have a good one.